So we start with equation 15.6a for the coefficient of performance COP of a refrigerator. So that is equal to the heat output over watt done, which means that the watt done will be equal to QL over COP. Now let's divide time on both sides. So we have W over T, which is the rate of work, equal to QL over T, which is the rate of heat output over COP. So now we can substitute all the values. So we have this equal to 5 tons over 0.18 times the ideal COP. Now 5 tons will be equal to 5 times 909 kg per day, and that per kg we have 3.33 times 10 to the power 5 joules. So that gives us the total power output, rate of power output divided by 0.18, and for the ideal coefficient of um, performance, so that is equal to 273 plus 22k, 273k plus 222k over 13k. So 22 is the highest range of temperature, and 13 is the difference between the highest and lowest range of temperature. So basically, let me just write down the formula. So the ideal formula for COP is TL over TH minus TL. Uh, uh, okay, so this is actually the lowest range of temperature. I'm sorry about that. And we need both of these temperatures substituted in units of Kelvin, and that's the reason we added 273 to 22. And TL is given to be 22 degrees C, and TH is 35 degrees C. So the difference in Kelvin makes it 13 Kelvin. So we have already plugged that over here, and TL in kelvins will be 22 plus 273. So that's the ideal COP. Now solving that, basically calculating that part, we find W over T to be 3.705 times 10 to the power 8. Oops. Let me just rewrite that part. 10 to the power 8 joules per day. Therefore, the cost per hour will be equal to this, the rate of work done times. So this is in joules per day. So we must convert this into joules per hour. So we have 24 hours in a day. So we divide that factor, because we have days in the denominator. So we divide the factor times we divide the number of joules in 1 kilowatt hour. And finally, The cost is given to be $0.1 per kilowatt hour. So we multiply that. So basically over here we converted the power uh, in units of joule per hour. So power is now joules per hour. Then multiplying with this factor, then we get the power in units of kilowatt, just kilowatt. There is no R because the R just cancel out. And then multiplying that with this factor, we get the rate as some price or cost per hour. And this R comes from the R in kilowatt hour in the numerator here in the last term. So that's how we find the cost, and calculating this after substituting the W over T, this factor over here, we find the cost per hour to be 0.43. This is per hour. Thank you.